All right, let's do some experiments, shall we? Come on, baby. I got my stir bars going. This one doesn't look like it's spinning, does it? That's because the rate at which it's spinning is almost identical to the frame rate that the camera is operating at. Let's pour some water in these flasks to get our experiments going. There we go. All right, we'll get this one going over here. Let's see what kind of vortices we get going. Got a nice one over there on the right. It looks like that one on the left is taking a little time to get going. I just want to add just a little bit more fluid to the one on the left. A little OCD about making sure the levels are kind of the same. Yeah, I'd say that looks okay. And now I'm going to start adding a little bit of universal indicator to each flask. Universal indicator is also known as rainbow indicator. Now let's turn this on so we can see a little better. Right here, these are the different colors that the universal indicator will display at different pH values. pH just tells you how acidic or basic something is. So here we go. Right here you can see that universal indicator. It's a green color. Let's see what happens when I put it into the distilled water. See a shift to a yellow, don't you? Why in the world, if you look at yellow, that's slightly acidic. See that? pH 6. Why in the world is pure water slightly acidic? What do you think? Nice, Tommy plays. Oh, what do you think? Why is distilled water, which has been highly purified, why is that slightly acidic? What the heck is going on there? Does that make sense to you? Probably doesn't unless you know the trick. I don't want to say the trick. I should say the chemistry. Why is highly purified water somewhat acidic? Anybody know? Autoionization. That's a great guess, Shri J, but you got to remember. Come on, Josh F.O. Josh F.O.'s got it. Look at Josh F.O.'s comment, baby. Josh F.O. wins the comments for now. So autoionization, obviously that's going to produce protons, but, hydronium, but it's also going to produce hydroxide. So since those will be the same in neutral water, that's not going to be the cause. Josh F.O. has it. Dissolved carbon dioxide from the air actually dissolves into this and makes it slightly acidic. If you stir something counterclockwise, will it unmix the ingredients? Not in this case, Burrow. Not in this case. Okay, now what I'm going to do is I'm going to add just a little drop of sodium hydroxide. That's a base, 20% by weight. Sodium hydroxide over here on the right, just one drop. Boop, in it goes. And look at that gorgeous color change, huh? Isn't that beautiful? Now we're going to do the same thing over here on the left. One little drop of sodium hydroxide base, 20% by weight. In it goes. Look at the gorgeous flow pattern. Thank you there, Chad. Yeah, we got a nice little color change there. Now we're going to add some hydrochloric acid. This is the same acid that's in your stomach. It's just like 100 times more concentrated. Like one drop of this stuff has more acid than's in your stomach. So here we go. I'm just going to add one drop over here on the left. You see that red color grow in? That's telling you there's some acid that's been added. Thank you there, Zachariah. Return to the, look, we got a little rainbow action going on. That happens sometimes. Let's add another little drop over here on the left. The rainbow, I'm going to add a drop over here on the right too of hydrochloric acid. Look at that gorgeous color over there on the left. The right's looking pretty too. Can I put, Chad, I don't have any sodium down here in my basement. How do you have so much acid all the time? Do I? No, I don't, buddy. I just know where to buy it. It is beautiful, I think. Here, let's do another drop of hydrochloric acid on the right over here. You can see me adding it. There it goes. In goes the drop. It's like a little bit of the Northern Lights. Anybody see the Northern Lights yesterday? I got to see them. They were beautiful. Oh, we got rainbow action going on over there. Hey, I have an idea. Pick a chemical to drop in the chat, and you need to guess the color. So I see some blue. Oh, nice. Here we go. I'm going to add another drop of acid over here on the left. So yeah, you can tell that right here by looking at these different colors and the different pH values. That tells you how acidic or basic the flask is. Right now we're at pH 3 or lower. So the indicator I'm using from pH 3, 2, 1, keep on going down, this will stay red. And at pH 10, that's the high end that the indicator will display. So Zachariah wants some green. That's tough to get, but we're going to go for it. Here we go. To get the green, I need to neutralize the acid, so I'm going to start adding base. The base, I'm adding sodium hydroxide. We're going to do 1 drop over here on the right for Zachariah. You can see me get that green. Ah, Chad says clear. Chad, I've already accomplished clear. Now, you're going to hate me for this. Man, getting the green is tough. You're going to hate me for this, but check it out. This already is clear because you can see through it. That's what we chemists, I'm sorry, I'm a chemist. I'm going to have to do this. I got my teacher hat on, but it's already clear. We use the term clear for transparent. I know you know that. What we're going for is colorless, and that I can't do. I'm doing pretty good there, Simon. And I got your green. I got the green. Come on, baby. That's hard to get. All right, let's neutralize the base. I'm going to add some hydrochloric acid, the same acid that's found in your stomach over here on the right. There goes 1 drop. See that red color? We got the whole rainbow, baby. Oh, no, that's transparent, Chad. Absolutely. This is green and clear. Yeah, it's green and clear because you can see through it. So we chemists use the term clear synonymously with transparent. So this is transparent and green or clear and green. This over here is clear and yellow or transparent and yellow. What I'm pretty sure you mean is colorless. That's what you want. Thank you there, Make It. All right, let's add a drop of acid over here on the left. Hydrochloric acid, same acid that's found in your stomach. And now we're going to add base to both. Here we go. 1 drop of base, sodium hydroxide base. That's a strong base. In goes 1 drop, in goes 1 drop. See some nice flow patterns. Really beautiful colors. How you doing there, Soy the Best? Simon D. Isn't it amazing when a traffic light is green, you are also clear to drive? I'm loving it. We got some dad jokes in the chat, or maybe mom jokes. I'm not sure which, but here we go. Over here on the left, I'm adding a drop of hydrochloric acid. Over here on the right, adding a drop of hydrochloric acid. Hello there, Emir, and hello, Games. Hey, Ron. Hey, a scientist is just somebody who's trying to figure stuff out, man, and using certain principles to do it. So I'm sure you're a scientist at times. We all are. This is kind of fun. I'm going to go ahead and turn the stir bar off over here and then add in a bunch of acid. So the acid I'm adding up here at the top is hydrochloric acid, the same acid that's found in your stomach. You can see now we have a pH of 3 at the top, but a pH of 10 at the bottom. And this is really interesting. Dome, I don't know what you mean by that. Name a car for an edit. I apologize. I don't know what you mean. But anyway, we got a pH of 3 here at the top, pH of 7 here at the bottom, because the pH scale describes concentrations of acid that go as power of 10. As they go as power of 10, a difference between 10 and 3, that's 7, isn't it? And 10 times 10, 7 times is 10 million. So the difference in acidity between the top and the bottom, the red and the violet, that's a difference in acidity of 10 million times. Now turn it up in the opposite direction, and I can't. It always stirs in the same direction there, Life Under. Ask why the acid concentrations as the pH decreases. Josh wants to know. Josh is asking the chat, why does the pH go down as the concentration of acid goes up? That's a tough question if you haven't had chemistry before. I'm going to add some. Now we're like low pH. I'm going to add some base here to both sides to get some color change going on. If you drink that, will you get heartburn? Chad, if I drank the whole thing at pH 3, probably. If I drank a little bit at pH 3, Probably not. The issue is, however, is one of the dyes in the indicator system that I'm using is a laxative. So I am not going to be drinking this anytime soon. You can drop an emoji in the chat that might describe what would happen to my afternoon, or excuse me, my evening if I drank this stuff. So Perla asks, how did that blue turn to red? What happens if you put a Tums in it, asked Chad. What a great question. What a great question. I don't have Tums, but I have some milk of magnesia we could try. I do have some of that. So let me explain what's going on here. There may be some new folks here. So right now, both flasks are violet. And in each flask is just some water with some universal indicator. It's just a mixture of chemicals that changes color depending upon pH, which is how acidic or basic something is. I see you, Patrick. I see you, Patrick. So right now we see the pH is 10 because it's the violet color. That's very basic or very alkaline. And then if I want to neutralize the base, I'll need to add acid. And the acid that I'm going to be adding is hydrochloric acid. It's the same acid that's found in your stomach. So I'm going to add one little drop here on the right. And let's do 2 drops over here on the left. See what happens. And you see, as I add 1 drop, I can see some red in the middle where the acid kind of remains. And oh, look at that over here. It looks like I added an excess of acid. The pH dropped from 10 all the way to 3. So we went from base to acid. I'm going to try to get this neutralized. It's not the easiest thing in the world. I'm going to try to add a half a drop. You notice I had just a little drop right there. In it went. And now you can see, oh, it's a little, let's see where that ends up. Kata is studying this right now. So long, Simon. Thanks for hanging out. Thank you there, Leslie. I don't know what that means, Goof Alert. I don't know what it means. I'm too old, man. I'm not up with the current slang. All right, in goes a little more acid. Hey, look at that. I've neutralized it. Pretty much. I mean, I'd say it's pH 8. So we drop from pH 10 to pH 8 over here on the right. Hello there, monkey boy. All right. Love you too, Aiden. Hey, thanks there. So fun. Oh, thank you, Derek. I won't Google it. Hello there, Tate. Thanks for joining in. Zinc and fluoride. All right, here we go. I'm going to add a drop of acid over here on the right. In goes the drop. And let's add some base over here on the left. In goes the drop. It's kind of like Northern Lights, chemical Northern Lights. All right, the comments are coming through pretty quick here in the chat, so forgive me if I don't get to all of them. Here we go. Let's add a drop of hydrochloric acid over here on the left. Never finish. I don't know, man. Chemical Northern Lights. You love it there, lover girl. Thank you. Add acid into base. That's what I just did over here, but I'll do it again for you. Look at that. We got the chemical traffic light going on. Over here, I have acid, pH 3. I'm going to add base into it, okay? Here we go. Here we go. Add a drop of base. 1 drop. The acid and base are reacting with each other. Look at that gorgeousness. It looks like I added an excess of base because I shot straight through neutral all the way to pH 10, which is basic. Thank you there, Tanya. I appreciate it. Put all 6 acid on one place. Timothy, I apologize. I don't exactly know what you're trying to get at. KTA, I'm going to try to get it to pH 7 for you. So here's what we got to do. Watch what happens. I'm going to go ahead, Elephant's toothpaste. I'm doing that actually this weekend. I'm doing a show for a bunch of kids. We're going to do some elephant toothpaste. So I added a drop of acid to this. It was at pH 10. It looks like I overshot neutral. See, we're at like pH 6. It's really tough to get to neutral, but I'm going to give it a shot. First, I'm going to make this one over here acidic. And then I'm going to add a drop of base to see if we can't get that green color to develop. Give it a go. That's crazy, guest. That's a lot of Oreos. Can I make a bigger tornado? We can try. We sure can try. I'm going to turn up the speed right here. You see these buttons here? So here we go. That's correct, IU. Here in the United States, we use base and alkali as synonymous with one another. Why does dissolving sodium hydroxide make a bunch of heat? As never finished. That's because there's two things that go on when you dissolve a salt like sodium hydroxide. The first thing is you have to put energy in to break apart the ions. So there's sodium ions. That's usually what happens when I speed it up too much. There's sodium ions and hydroxide ions in sodium hydroxide, and those have to split apart to dissolve. That takes energy. However, after dissolving, the ions get attracted to water molecules. And when that happens, energy is released. Now, if more energy is released on attracting to the water molecules than is required to separate the ions, then you get energy release when a salt dissolves. And it just so happens with sodium hydroxide that the energy released on attraction to water molecules is ginormous, and that's what generates all the heat. If you were to drink this, Swag Boss, it would ruin your evening. One of the dyes that's in here is a laxative. It used to be the main ingredient in X-Lax. What's a base? Lovely. It is the same thing as alkali or alkaline. Here in the United States, we use the term basic and base, synonymous with alkaline and alkali. Yeah, I could probably make your credit card dissolve. You know, your average Walmart bag, you can go for it if you want to, but I won't be joining into that party. Here we go, another drop. What makes the pH color as pyros? Thank you there, Neffy. I kind of feel like I need a voice coach, but I appreciate the positivity. So what makes the thing colored? Here, let's talk about this. This is a little complicated, but it's not too bad. I'm going to try 8 unto. I'm trying there, Evil. It's close. Come on, we're close. It's like a greenish yellow. So what makes the color changes? Let's just talk about one of, see, there's like 4 dye molecules in this solution, okay? We're just going to talk about one of them. And the one we're going to talk about is phenolphthalein. And what phenolphthalein does is it provides these, it adds these colors to the solution. So there's no color, you know, the phenolphthalein adds no color when it's at pH 3 through 8. But when it's at pH 9 and 10, it gives the mixture a pink color. And that adds to blue to give us violet at the high pH. Now, phenolphthalein, it's a ring-shaped molecule. I think there's your neutral. I mean, we'll just try a little bit. So phenolphthalein is a ring-shaped molecule. And when there's a lot of acid around, there's a lot of what we chemists call protons around. And we're gonna symbolize protons by this white thing here. And the phenolphthalein molecule, what it does, if there's protons around, it grabs onto that and it makes a ring-shaped structure. Now, when the phenolphthalein molecule is like this, it's colorless. Now, when it gets basic, the opposite happens. In a base, the protons get removed by the base. Boop, it gets taken away from the phenolphthalein. And when that happens, the phenolphthalein molecule pops open like that. And with that change in chemical structure comes a change in color. So it's colorless, colored, colorless, colored. And you can just, adjust the color of phenolphthalein by changing the acidity or basicity. Thank you there, Poppy. Thank you there, KTA. Appreciate it. Saying some Nile Red stuff. You know what? That's true, but I got to tell you, I've been doing chemistry experiments since before Nile Red was born. So it's just the truth, man. It is the truth. I mean, I love him. He's great. I love the experiments he does. But, we chemistry teachers have been doing that stuff for a long time. Considering all acid drops you put in those cups turning red to purple, are there any problems to drink it? Israel, I wouldn't want to drink this, although we drink stuff that's at pH 3 all the time. Like Sprite, any carbonated beverage is probably around pH 3. Orange juice is around pH 3. So it's not necessarily just like the acid that's bad for you. For example, ascorbic acid, that's also known as vitamin C. Oh, epic. That's good to hear. So yeah, I mean, there's, all the chemical definition of an acid is it's something that donates protons. There's your green. I think we got it. No, I can't make that. I can't make cherry soda out of paint thinner. I am not what they call a synthetic chemist. Not at all. I am more a physical chemist that's kind of more theoretical. I just like studying stuff and figure out what's going on. So pH and 6 or below considered acid. That's right, Samir. What am I adding? Adding. I'm adding hydrochloric acid, 20% by weight over here on the right. Over here on the left, let's add it here. And then I can add 20% by weight, sodium hydroxide over here on the right, over here on the left. And you can see what happens to the different colors and see the various pH values. I can't, Poppy. Walter White was what we call a synthetic chemist. I would say now red is kind of like a synthetic chemist. Synthetic chemists are chemists who make stuff. So they start with certain starting materials and then they try to figure out how to, make something new out of it or how to transform the material. I'm more of a chemist who likes to understand the processes at work and to try to explain what's going on rather than just, it's less kitchen chemistry, it's less cooking and more understanding. Man, I ain't sticking my hand in that. Can I make it crystal clear? I cannot. Let's do one special keynote. Let's do a different chemistry experiment. You want to? Let's try it. So we got these going on. I want to do a different one here. So we're going to just take this off. It's going to be similar. It'll be similar, but somewhat different. This case, I'm just going to put a new flask on here. We can turn this off. Yeah, let's get this. We're still going to need that. So we got something to look at. I'm going to slow this down. Let's actually make this acidic while I'm getting the other experiment ready. So I've got a lot of acid in there. And then I'm going to turn this off, and we're going to put some base in up here and kind of see what happens. There we go. See what happens over time as the acid and base mix over there on the right. Hello there, Master Pilot. Okay. So what we're going to do over here on the left, some water. All right. And so it gets mixed. I'm going to go ahead and put the universal indicator in. Universal indicator shows these color at different pH values. We're seeing that happen over there on the right. Thank you there, Geo Cruz. Hello there, The Walk. You got it. I was talking about the changes in the electronic density of the molecule. That's what's going on. You're going to change the absorption spectrum. So notice the universal indicator in the vial is green. And when I add it to the water, this is pure water. I mean, no water is entirely pure, but this is distilled water, which is very pure. It's yellow, which is pH 6. That's an acid. What the heck is going on with water that's pure? Here it is, distilled water. Distilled water. What is going on with that stuff being slightly acidic? The reason is that there is carbon dioxide in the atmosphere. And when carbon dioxide is in the atmosphere, it dissolves in water. And when carbon dioxide dissolves in water, it makes an acid. Tangerine, I'm getting ready to put something in there. We're getting close. So the carbon dioxide that's dissolved in the water is making this slightly acidic. Come on, man, that can't be. Well, here, let's show you. I probably should put a stir bar in here to just get that mixed up. Get that going. Get the colors mixed up. And I'm going to make it basic. All right, that's nice and purple. Look at those beautiful colors over here. It's like the chemical northern lights. Okay, now what I'm going to do is I'm going to add some carbon dioxide to this. I told you carbon dioxide is an acid. All right? So if I add carbon dioxide to that flask over there on the left, the pH should drop. How am I going to add carbon dioxide? I'm going to add carbon dioxide by adding dry ice. Dry ice is carbon dioxide. It's solid carbon dioxide. So in it goes. And if carbon dioxide is indeed an acid, we should see that pH drop as the CO2 bubbles through the solution. Oh, it's pH 9, it's pH 8, it's pH 7, it's pH 6. That's what carbon dioxide does when it goes into water. It lowers the pH. Alana wants to put their hand in it. Carbonic acid, you got it, Singram. The chemists have entered the chat. TC, I could blow into it, but that's not going to give us quite as much acidity as the dry ice. Okay. That's a funny comment, Meta. No, it won't quite get to pH 3, but if you look up here at the top, you can see some it's like a 6 or 5. All right, here we go. I'm going to add a bunch of base over here. So in it goes. And the carbon dioxide is just totally consuming the base that I add. Here we go. Let's add a bunch. I'm going to add a big old squirt. Try to make that stay purple. The walk. I wouldn't want to drink this because one of the dyes in here is a laxative. That would ruin my evening. Is it strong enough to consume metal? Not really. Not really. No. What happens if I put my hand in it? Nothing. I mean, it's not going to hurt me. It's not nothing bad. Why is it darker on top? I assume you're asking this one over here. What's going on over here is this solution started basic, which was a high pH, and then I added some acid to the top, which is the pH 3, and some of that acid is slowly dripping down into the lower part of the solution. It's neutralizing the base. Now, let's go ahead and mix everything up, and if I have an excess of acid, everything should turn red. Let's see what happens. What is universal indicator, Coolio? It is a mixture of 4 chemicals. Those chemicals are thymol blue. They are bromothymol blue, methyl red, and phenolphthalein. Here, this is what it's made of. All of these. And each different dye, each different indicator dye shows different colors at different pH values. And when you add all 4 of them up, you get, the colors of the rainbow at the different pH values. That's the basic idea of how universal indicator works. Let's add a little bit more base over here on the left and let that carbon dioxide neutralize it again. What is considered drinkable in the universal indicator scale? People drink water that's pretty high in pH. People buy alkaline water, and that's going to have a pH of roughly 9. And people will drink things all the way down to stuff that's like a pH of 2. Mostly people enjoy foods that tend to be slightly acidic. So, like lemon juice, lime juice, sodas, pop, that tends to be, your lower pHs. What does pH 1 look like? Here, let's show you. Oh, well, pH 1, so pH 3 and below, it's all going to look red. So anything below pH 3 is going to stay red. Anything above pH 10 is going to stay violet. Ohio man, can you be able to make it explode or make it blue or blue foam? I can make it blue, but I'm not going to be able to make anything explode tonight. That's not going to happen. But let's try to make it blue for you. Blue's kind of tough. Emmanuel, is what healthy to consume? That's right, Giannis. Plants do a good job of that. Are the primary colors related with the pH? Not really. So what I'm guessing, Geo, would happen if we mix the indicator with a super acid, I would imagine that I went past blue. I imagine that the indicator's dyes would decompose in a super acid, and we might actually see things go to like a yellow or a maybe colorless. If you add acid to first flask, will it become acidic or become neutral again? Is this the first flask, or are you calling this one the first flask? I'm trying to make blue for you there. I told my mom that Breaking Bad near instant dissolving a body with acid was not realistic, and she doesn't believe me. Pyros, no, I think you could actually dissolve a body with some acid. You could indeed do that, as long as it's concentrated enough. Nothing, man. Nothing. I mean, that pH 6 is like nothing. You got it, Ohio man. Alina wants to drink it. More power to you. What gases come out? Asked Joe Doc. I don't think there's many gases coming out of this at all. Is calcium chloride a base? Super slim. I want to, if you don't mind, I'm just going to correct you there just a little bit. And I know you probably just couldn't put it in, but calcium chloride has 2 chloride ions for every calcium. And calcium chloride is a neutral compound. It is not a base. Can I drink it red? I could, but you know, if I drank a little bit, it wouldn't be that big a deal. You can drink it when it's red. You sure can. I just wouldn't want to because it would ruin my evening because one of the dyes in there is a laxative. Yep, you can go ahead and put the emoji in the chat that would describe what would happen if I drank this stuff. Sure, yeah, we got a little bit of H2O gas coming out, a little bit. What's the coolest thing I could do right now? I'm not really sure. You got it, Her Eminence. Oh, I love the emoji. What the heck? That's a pink Cosmorn. Man, I'm loving the emojis. Those are hilarious. This can dissolve metal. Both these can dissolve metal for sure. Both these. The emojis are cracking me up. I love the tangerine arts. I love the pink excrement emoji. Add acid in the dry ice once, okay? So I'm going to go ahead and wait till the dry ice acidifies this. You got it, Sans. Alina. What if I drink it? Yeah, I think we've answered that. Oh, nice. So does the acid mean it has more electrons? No, an acid, the way we chemists... Okay, here we go. Someone asked to add acid to this this side over here, and it goes. In goes a little more acid. So really what we end up having over there, for any chemists in the chat, you might notice we have a buffered system now. And that's because the carbonic acid has reacted with a lot of the base that I have been adding, and that's going to form a carbonate-bicarbonate buffer system, and that's going to keep our pH really close to pH 6. It actually might be bicarbonate carbon dioxide. I think that's probably more likely. It's a carbon dioxide bicarbonate buffered system. And so adding acid or base to this over here is not going to change the pH a whole lot. So somebody asked do acids have more electrons in them? Really, the way we chemists think about acids is, and let me add some base over here. Acids are proton donors. So there's this little chemical, this little ion, I should say. It's the H plus ion. We symbolize it like that, H plus, and acids donate this thing. So acids are proton donors. Bases are proton acceptors. So a base grabs onto those protons. Hey, thanks, Airsoy. I appreciate the sub. Yeah, if you consider doing that, it might help out. We're trying to hit I do everything on the channel, so I'm trying to hit 500,000 subscribers. Protons, hydronium, the chemists have entered the chat. I love it. What happens if you take a bite of dry ice? I wouldn't do it. Wouldn't do it. Turn fire blue. H plus. Wait, is the best. Hey, thanks there, Clappies. Hey, thanks there, The Walk. I appreciate that. What is negative pH as pyro? So a negative pH... Okay, I usually lose people in the chat when I start talking about this, but let's just talk about it real quick because I don't want to get too mathematical with folks. This is the mathematical definition of pH. It's the minus log base 10 of the proton concentration. So what that basically means, if your proton concentration gets higher than 1, your pH goes negative. So the higher the proton concentration, which basically means the more acid that's around, the lower the pH, the higher the acid concentration. Can dry ice freeze your hand? Yeah, it sure can. Come on! PPSIR, pH, POH is 14. We got it. What's my favorite element? Asked Tangerine. Hydrogen. No question about it. I love hydrogen. It's the basis of the periodic table, and it's actually the basis of pretty much all material in the universe. Like 90% of the atoms in the universe are hydrogen. It's quite remarkable. What do I do with my hair? Let's put this back on here. What happened to my other flask? I don't know what happened to it. What did I do with it? Well, we'll just get this one running. We'll just get a new one running. You guys probably want to see this get started anyway. All right. BA Legend also likes hydrogen. Hey, why don't y'all drop in the chat your favorite element while I get some acid in here? I want to see some of those favorite elements. Hello there, Analia. What if you mix both those jars, asks Ohio Man? Let's do it. Come on, let's do it. So what? If you're paying attention, you'll know what's going to happen. So here we go. We're going to mix these together. I love this experiment. So Aurora, you made some, yeah? I've done that too. Check it out. Check out my shorts, my YouTube shorts. I've got some videos on there where I make some thermite. A lot of fun. I dress like Heisenberg when I do it too, because you know he did it. It was a lot of fun. We do goofy stuff like that from time to time. Okay, so somebody asked what's happening, so I can go ahead and just molybdenum, titanium, krypton, neon, plutonium, radon. Cool, man. Wolfram, tungsten, loving it. Titanium. Sodium, iron, seaborgium, carbon and hydrogen. I'm going to make it purple, Analia. Magnesium, sodium, carbon, nitrogen. I'm loving them, man. We got all the big ones. Shoulder, that's a planet. Photosynthesis. I studied that for my PhD. I studied photosynthesis for my PhD. Uranium, oxygen, uranium. Bromine, hematite, that's a compound. School propaganda is real for carbon. Make it gray. I can't make it gray. Unobtainium, I love it. Okay, here we go. Silver, Lawrencium. Okay. All right, here we go. I'm going to add some universal indicator over here on the left. Universal indicator is a mixture of chemicals that changes color depending upon pH. And pH is just a description of how acidic or basic something is. So over here on the left, we see that the color is yellow. And that tells me, hey, let's get our pH scale up there with the colors. The yellow color tells me in this flask on the left, the pH, that's yellow, that's 6, which is just slightly acid. Just slightly acid. Now over here on the right, this is red, so my pH over there is 3, which is also acid, but it's more acidic. So now what I'm going to do over here to the flask on the left is I'm going to add some base, some sodium hydroxide base. And when I do that, we get violet. So we made a pH 10. It's very high pH. So the question Ohio Man has been asking and other people have been asking is, what happens if I mix these two together? Well, let's find out. Here we go. All right. So here's how we're going to do this. I'm going to take this off. If you've been watching the chat, you know what's going to happen. So I'm going to go ahead and take squirts of each, and we're going to stick it in the middle. We're going to keep doing this until, I don't know, until we see something. Here we go. So here we go. We got red and violet. Add together. Red and violet. Red and violet. Red and violet. Red and violet. What's the difference between a strong acid and a will? Well, let me just do the experiment here. And I'm just going to try to... There we go. Looks like we got yellow, yellow, green. So these two, what they do when you mix them together, if I get balanced amounts, yeah, another squirt of that. I'm trying to add a little bit more base. So if you add equal amounts of acid and base, what happens is they neutralize each other. So I added the pH 3 and the pH 10, and when you add them up in the right amount, you get neutral because acids and bases neutralize each other. It did look like that for a bit. Yep. Doing the Lord's work, says Dylan. Thank you. I appreciate that. Appreciate that. Very nice. Is it possible to do primary colors then mix it up to get secondary colors. Israeli, that's not exactly how this works. This more works on, acid-base neutralization principles. I'm going to turn both these off. And to this flask on the left, I'm going to add some acid. And to the flask on the right, I'm going to add some base, and we're going to watch it slowly react. You know, it doesn't homogenize immediately. It looks like we got the Northern Lights in two different flasks there. It's not litmus. It's a universal indicator. The tornadoes have different sizes because I spin them at different spin rates, and they also have different size stir bars. Silver azide, I've never made it. I did make that Minecraft. Go check out my short videos. I actually put a scrub daddy in some of that, in that solution. How do you make that whirlpool? It's just a magnetic stir bar that's on a magnetic stir plate. So the stir plate, you can think of that inside this box is like a fan with magnetic blades. And when the fan spins, it makes that little magnet on the inside of the flask spin. Put dry ice in one, then spin it fast, because why not, says Glorious. Yeah, we might do that. It is pretty. It is kind of pretty. Let's spin them and see what happens. So as I spin them, if we have an excess of acid, it'll be yellow, orange, or red. If we have an excess of base, it'll be aqua, blue, or violet. And if it's neutral, if they exactly balance each other, it'll turn green. Let's find out. Here we go. It looks like we had an excess of acid over there on the left. Let's see what happens over here on the right. Great question. Why doesn't it explode like baking soda and vinegar? This is why. So the reaction here, I'm going to turn them off, and we're going to go ahead and add now acid to this side. And we're going to add base to this side. And watch what happens when I answer this question. So baking soda and vinegar, that's an acid and base reacting. And when those two react, they form carbon dioxide gas. And that production of gas is what forms all the bubbles. In this case, the acid is hydrochloric acid. The base is sodium hydroxide. And when these two react, what you get is water and salt. There's no gas that's being produced. And because there's no gas being produced, you're not going to get it to explode or bubble like that. Put a hot dog in pH 3. Did I know that alligators eat fish, blue crabs? I know they eat a lot of stuff. The one on the right looks like a tornado. It does a little bit. It's really beautiful. And you can see like the whole rainbow in there. I kind of like this because when it's spinning fast, the acid and base homogenize very quickly. And so this reaction happens very quickly. And the solution homogenizes to a particular pH very quickly. But when you turn it off, you see these different pH regions that persist. Rare, like some xenon. Sprite is an acid. I actually have some soy. Hold on a sec. We'll test it for you, okay? I actually have some Sprite. Give me a second. I'll get it. And we'll test it. All right. Here we go. So I've got some Sprite Zero here. Never been opened. All right, and we're going to go ahead and test this with the universal indicator, okay? And while I'm doing this, let's add a little bit more acid over here on the left so we get some pretty colors going on. There we go. Okay, so I'm going to go ahead and open this. Opening the Sprite. Here, look there. You can see it's never been opened. It's actually kind of weak. Can you see its expiration date? I can't read that good, but what's it say? Expiration date. I can't quite find it, but anyway, it's pretty old, but nevertheless, here we go. I'm going to open the Sprite. There it goes. Crack open the lid. See the bubbles forming. Let's add some universal indicator to this. Now, you might remember I told you that when carbon dioxide goes into water, it gets acidic. Yeah? So this should be acidic from the carbon dioxide that's dissolved in the soda pop. But they also add citric acid to lemon lime sodas. So this is going to be acidic. Let me just stick that right there. Don't fall. Don't fall. Don't fall. If that falls, I'm not going to be happy. Okay. All right, here we go. In goes the squirt of, look how red that stuff is. Come on, baby. That's exactly what I'd expect, huh? Of course, there's a bunch of acid in here. A ton of acid. Let's shake that up. And you can see that red color go all the way through the Sprite. So my universal indicator that I used here, we tested some Sprite, and we indeed showed that the Sprite is acidic. It's at least pH 3. It could be pH 2 or 1. The unfortunate thing about universal indicators, once you hit pH 3, it stays red all the way down. You know, I saw that comment. You know what? It is indeed a waste of food. You can look at it that way, but you can also look at it as we're doing some science and learning some stuff. Yeah, either way, I'll own it. I wasted some food, but there may be some folks out there that found that interesting, and if that's so, then I think it maybe not have been a waste. Okay, what does pH mean? As Rivi, it means mathematically the negative log base 10 of the proton concentration. Okay, here we go. We're going to mix these up. And when I mix these up, if there's more acid than base, this will be red, orange, or yellow. If there are equal amounts, it'll be green. And if there's more base than acid, it'll be aqua, blue, or violet. Here we go. Let's mix that baby up. Is Sprite without CO2 also acid? It is, because they add citric acid to it. Hey, look at that. I think it may be perfectly neutralized. Look at that. I added the perfect amount of acid and base. The two reacted, and they neutralize each other. Okay, let's try this over here. Once again, if there's more acid than base, it'll end up being red, orange, or yellow. If it's more base than acid, it'll be aqua, blue, or violet. And if they're perfectly balanced, it'll be green. And if the stir bar doesn't work, then we won't figure anything out. Here, let's try her again. That's correct. LSD is actually an acid. Yeah, you could. Butterfly pea flower, iron scythe. I recently did a video on using butterfly pea flower. So this one is slightly basic, so I had a little bit more base in. That's why it's pH 8. It's just above neutral. Isn't that cool? All right, let's get this one basic. I'm adding base now, and you can see the pH increases. We're going to get this one over here acidic. I'm going to add acid. The acid that I add is hydrochloric acid. It's the same acid that's found in your stomach, except this stuff is a lot more concentrated. So it's like 1 drop of this stuff has as much acid as like 10 human stomachs. Okay, here we go. I'm going to turn these off, and we are going to add a bunch of a bunch of base over here. 4 drops. And then on this side over here, we're going to add 4 drops of acid. I did 3, didn't I? Let's do a 4th. And it's like we're seeing the northern lights, the chemical northern lights. I see you, Minecraft. Thank you there, Rivi. Appreciate that. I don't have litmus paper. Can you use your stirring machine to charge your phone? No, I can't. Xylon, that shows a wide variety of pH values depending upon what you've been eating. It is pretty, isn't it, Katie? Millie, what this is water to which I've added a special mixture of chemicals that are called universal indicator. We use it just to test pH. The different colors that you see are telling you how acidic or basic each region is. The more red it gets, the more acidic it is. The more violet it gets, the more basic it is. And if you see green in that region, it's neutral. Thank you there, Only Talent. I appreciate that. Cosmic, we're testing pH and just having a good time. Thank you, Only Talent. I appreciate that. I really do. Thanks for everyone who, decided to follow me. I appreciate that. Finley, I've been doing this about 49 minutes tonight. I think it's white. That's the color that you're looking at. Does sodium affect base or acidity? It does not. So sodium ion does not. The sodium ion does not affect acidity or basicity. I've done that, Jason. I've got a shorts video on that. If you go through my shorts video, that one's about 2 years old now. we put some copper and nitric acid. It's really cool. Thank you there, Minecraft. Yes, it can, Jamil. Dylan, thank you. Tell me about it, right? I mean, particles are simple. People and politics, come on, man, that stuff's complicated. What is more acidic, sulfuric acid or hydrochloric acid? Roasting. I actually did a video on this. So here's how you tell this. If you put sulfuric acid onto sodium chloride, the the sulfuric acid will protonate the chloride ions and it'll foam and form HCl gas. And that tells you empirically that sulfuric acid is a stronger acid than hydrochloric acid. Hey, check this out. We got an interesting little, look at that. You see it? You see it's like a little bit of a pH gradient. And you can see the whole rainbow right there. That's awesome. That's really cool. And over here, it's like more, I don't know, like less linear and a little bit more just beautiful. All right, so here we go. No, Revoltness, I don't have any other experiments. Smoky, I wish. I've never messed with fluorantimonic acid, but I would love to. Jodoc, it depends. A lot, BA Legend. Is acid lighter and that's why it's always on top? Well, let's test it. Let's just test it, all right? Here we go. I'm going to mix this one up. Now remember, if there's more acid than base, the color will be reddish. And if there's more base than acid, it will be violet. Looks like I got more base over here, yeah? Let's try this one over here. Oh, that was gorgeous. This one, looks like I added the acid and base in even amounts, and we've got a neutral solution over here. Okay. So now what we're going to do is we're going to add a little bit of acid over here. See what happens? Yes, that's correct, Only Talent. We use alkaline, synonymous with basic, and alkali synonymous with base. Neutral with a bit of acid in the center and then a little bit of, yeah, you know what? I think you're right. So the base does seem to be a little more dense because that seems to sink a little bit more than the acid. Good catch, man. The most dangerous experiment I have ever done. Finley, probably making a piranha solution. That's pretty, I made sure I geared up for that one. And if you want to see the results of that, you can check out some of my short videos. I put a scrub daddy in piranha solution. How do you make this pH show? All you need to do is you need to get some universal indicator. So you can get some universal indicator. You usually buy this from science supply houses. You're going to get yourself a flask, a magnetic stir bar, and a stir plate. And then you're just going to add either hydrochloric acid or sodium hydroxide. Try to put acid in the middle while it's spinning, all right? We'll try it. Here we go. Get that going. All right, so we got her spinning. And now I'm going to start adding acid. I'm going to spin it slow. Okay, here we go. We're going to add acid here to the middle. Can you see it? Can you see the acid that kind of stays center? Isn't that beautiful? You're seeing a difference in pH of quite a bit between the middle and the outside. And then, of course, once the acid gets pushed down onto the stir bar and spread out over the sides, that's a neat suggestion there. Thank you for the subscribes. I appreciate that. Am I cloning? I am not cloning people. The sugars in soda do not affect pH. So sugars are not acidic, nor are they basic. So they do not affect pH. What are the commercial uses for indicators? If you've ever needed to test the chemicals in your pool, you end up, using acid-base indicators all the time. So thank you there, Millie Morgan. I appreciate that. Thank you there, Cosmic. What would happen if I drank the right one? If I drank either of these, it would ruin my evening because one of the dyes in there is a laxative. It's not something I really like doing a whole lot. I've never done it. And that's just good lab technique, right, man? You don't eat anything that's been in the lab. No, Gaz, I am not. Can you tell what the chemical formula or scientific name of universal indicator? So V roasting, it is a mixture of chemicals. So the mixture of chemicals in universal indicator include thymol blue, that's really the backbone of the indicator, methyl red, bromothymol blue, and phenolphthalein. Okay, to this one over here on the, thank you there, Millie, on the left, I'm going to start adding drops of base to the middle. And you can see that the base tends to stay in the center of the vortex. Of course, still it gets pushed down to the bottom. Oh, commercial uses for piranha solution. I mean, it's a great way to dispose of carbon-containing material. The issue is it produces a lot of carbon dioxide. Is a universal indicator itself an alkaline, acid, or base? Here, or neutral. Here, I'll show you. We can figure it out ourselves. So I'm going to go ahead and I'm going to get some universal indicator. I got to make sure I put this in a fresh, unused dropper. All right. Pay attention to these values here. We're going to look at the color of universal indicator straight out of the bottle. And you can see for yourself, it's green. So the universal indicator itself is going to be neutral. Hey, thank you there, Finley. I try to read as much as I can. Is base good or bad for you? That Minecraft, it depends what you're going for. So, you know, yeah, it just depends. If I have an upset stomach, I take a base to neutralize the excess stomach acid. I'm learning about monoprotic, polyprotic acid-base equilibria. Come on, baby. Quantitative analysis. I love that stuff. Minecraft, it depends. You know, it just all depends. It depends on the acid or base. I do like chemistry. Are acids electron acceptors? Okay, so Lewis, so a more general way to define acids, instead of speaking about protons, are with Lewis acidity and Lewis basicity. And in that case, you talk about electron pair donors and electron pair acceptors. With Lewis acid-base chemistry, the way you define an acid is going to be an electron pair acceptor, and a base is going to be an electron pair donor. That's the definition of Lewis acidity and Lewis basicity. Why am I ignoring Dominic? I don't mean to ignore Dominic. I'm just trying to answer a bunch of questions. Thank you there, TJ. How's the spinner work? It's just think of these things here at the bottom as magnetic fans with magnetic fan blades inside them. And then here, if I turn it off, there's a magnet right there. It's just a little stir bar. And if I turn the magnetic fan blades on, it turns a stir bar. Xylon, I'm loving it. Why isn't water green then? Can I put Okay, yeah. So why isn't water green? Ask Only Talent. Let's talk about that. Great question. Sorry it took me so long to see that comment. So let's talk about this. I gotta redo the experiment. So let me just pop this on here. Okay, let's talk about why water, which is a neutral substance, is not green. I hope I have a clean flask, because this only works if the flask is clean. I hope this one's been cleaned out. I don't know if it is or not, but we're gonna find out pretty soon. All right, so I'm gonna add distilled water to this flask here. And you know what? I'm gonna rinse it out first, just to make sure. All right, I'm gonna rinse this out first. Yeah, you can see there's some gunk in there. So let's rinse that out with the distilled water. Okay. I probably should do it twice. All right. So there we go. I rinsed that out twice with distilled water. So we should be good to go. So in goes the distilled water. And then we're going to add universal indicator to this. All right. So give me a second here. Let's add some universal indicator. Where is it? And, all right, it's green. And when it goes into the water, it turns yellow. What's up with that, right? I mean, that was distilled water, which is purified water. And yet, the pH doggone it isn't neutral. It's pH 6, which is slightly acidic. What the heck is going on with pure water being slightly acidic? Well, here's the deal. Any water that has been exposed to the atmosphere has carbon dioxide from the air going into the carbon dioxide from the air goes into the water, and when carbon dioxide goes into water, it makes the water acidic. You're like, come on, man, that can't be right. Well, let me show you here. Let's show you. So I'm going to move this over here. We're going to make this basic over here by adding a lot of base. Okay? And then I'm going to add some carbon dioxide to it. And if the carbon dioxide's an acid, the pH should drop, right? How am I going to add carbon dioxide? I'm going to add dry ice. Dry ice is solid carbon dioxide. So in it goes. And as I add that carbon dioxide, look at that beauty. Come on, baby. The pH is dropping. It's pH 8. It's pH 7. And now it is almost there. A little bit more. It's pH 6. So any water that's been exposed to the atmosphere will have carbon dioxide dissolved in it, which is going to make it slightly acidic. Here, I'll add a little bit more, base in there. You can see it. I'm adding the base. And as the carbon dioxide bubbles through, it makes it, neutralizes it, and it makes it acidic. Somebody asked, why do I have dry ice on hand? I went and bought it for the live. So that's Minecraft Pro. If I drank the universal indicator, oh, I missed a donation. I sure did. I'm so sorry. I appreciate that. Yes, you can make soda with dry ice. So here at the end of the live, I'm done doing experiments. I'm going to have to clean up the mess. So usually what I do at the end of the live, I'm going to warn you here. I'm going to flip the camera around. You're going to look at my ugly mug. I'm an old man. I'm a 56-year-old man in my basement doing experiments. So if you don't want to see that, now's your time to get the heck out of here. Arav, holy crap. Appreciate the donation. Whoa, I'm loving it. Really love it. What if I drink the universal indicator? Minecraft, we've answered that, buddy. We've answered that. Appreciate the donations very much. So I'm going to go ahead and flip the camera. We're gonna talk a little bit. Thank you there, Lank Sock. That is heavy, Jay. I appreciate it, man. Very, very much. Thank you there, Thomas. The acid I'm adding, Brave, is hydrochloric acid. It's just really, it's quite concentrated, which is why I got the gloves on. That's why I'm taking off. All right, we're gonna flip the camera around. I'm gonna talk to you all, let you see my ugly mug, and then that's gonna be it for the day for me. So here we go. Turn that thing around. There we go. I got these on so I can read the comments. They're my reading glasses. You see them there? Yep, they got readers in them so I can see what the heck's going on. Fire shades. I am the indicator. I love it, Minecraft. Can I store? I wouldn't store liquid nitrogen at home plasma. Only, you know what I do? I just save it. So as long as the liquid's acidified, it doesn't mold over. If the pH, I've noticed if the pH gets high, then mold grows in the liquid. I can't reuse it. But I just leave it. I just put it on the shelf over here and reuse it for my different lives. Can we have a house tour? Asked Jason. Maybe someday. Maybe someday. All right, thank you there, Thomas. Thank you there, Joyce. Thank you there, Kiki. I appreciate that. So long, Swag Boss. Thank you there, Jody. It's fun hanging out with you guys. Thank you there, AS. I appreciate that. I feel every bit my 50s, though, just so you know. Would oil be acidic? Xylon, it is not. Any advice for chem course? Revoltness is like any other human endeavor. You want to get good at something, you got to put in the work and figure out a way to make it enjoyable. Figure out a way to just love it. And, you know, if you can figure out how to love something and you do that for your work, you never work a day in your life. What's that bubbling? That's what's bubbling. Some of the experiments we did tonight. That's what's bubbling. Thank you there, BA Legend. I do not work with amalgamations. Do you, Jason? Millie, we're going to dismiss class pretty soon. Thank you there, Kiki. Oh, yeah, I work in chemistry, boo-boo. Thank you there, Thomas. Love the name. Thank you there, Revoltness. What did I study? I studied a lot of chemistry, lots of chemistry, physical chemistry. So I like physics, chemistry, and actually I studied photosynthesis for my PhD in a biochemical lab. So I had a real broad but narrow, I should say, not very deep, very broad-based learning that I did for my PhD. Oliver, thank you. Appreciate it. The shirt is neutral. Mal Solo wins the comments. That's right, organic chemistry. Thank you there, Eliza. Plasma, you can, if you get enough of it, you can store dry ice for a couple days, but yeah, it goes off. It sublimes away. Me too, Minecraft Pro. Xylon, I am. I have a PhD in chemistry. Oh, cool, boo-boo. Going to a chemical physicist institute to do homogeneous catalysis. I love it. Love it. Thank you there, Ab Scryon. I appreciate, excuse me, I apologize if I'm not saying your name right. Amalgamations are a cool kind of reaction. So, Jason, have you seen my video on Galenstan? So, Galenstan is an alloy of 3 metals, gallium, indium, and tin. It is a freaky substance. So get on my short videos. It's on my long form too. And check out Galenstan, the video I did on Galenstan. That stuff is wild. I don't know if that's really an amalgamation, but it's an alloy. Finley. I love it. Finley, what would happen if you swallowed the magnet and laid on the plate? Would you turn it to a helicopter? Finley, I love it. That's hilarious. Hello there, Larry Bird. Hello. Yeah, Poiki Bobo. Sorry I'm not saying your name right, but yeah, I do lives every now and then. Thank you there, boo-boo. Thank you there, Mal Solo. Appreciate you hanging out. My glasses are basic. Yeah, thanks for the subs, everybody. If you're doing that, I appreciate it. We're trying to get to 500,000 subscriber. What pH is saliva? Great question. I think that runs around neutral pH, but don't quote me on that. All right, folks, I'm taking off for the evening. I usually do lives at this time. If my wife goes to yoga, so when she goes to yoga, I kind of, I guess, debrief from the week by hanging out with folks and doing a live because it's fun, man. I'm having a good time doing this. So I appreciate you being here. You make my evening when you're here. And, just thanks for hanging out and checking out the beauty of science with me. I mean, it's a lot of fun. So I hope to see you all around and be looking for that science all over the place. Take the time to see a sunset. Check out the moon. Check out the sunrise. That beauty of science. It's all